This note is titled Lesson 5.2 Systems of Linear Inequalities. Let's review the inequality symbols along with their direction of shading with various types of linear graphs. So when you're looking at linear inequalities, you need to be able to read your symbol. Your symbol will tell you two things that you're going to need to know. One of them is what type of line should you have, solid or dashed, and the other is going to be which way should you shade, above or below. Above and below can look different for certain lines depending on how they're graphed. So we're just going to review how to determine which way to shade before we start adding multiple lines onto a graph and combining mixed shading. All right, so for less than, because it does not have an equal to, you do want to keep your linears dashed. So we have four slopes represented here. We have a zero slope, an undefined slope, a positive slope, and a negative slope. So we're going to keep them dashed. Less than means to shade numbers that are lesser, and so you're going to move in a direction towards smaller numbers, which in most cases will be below. So for example, here we're at -8, so smaller numbers will be below, like -9, -10, and so on. When you have a vertical line like the second graph does, you are not able to shade below. There is no above or below when you're reading a line that moves up or down. So again, look at where your number is located at. Our vertical is at 5, and so I want numbers that are less than that. That would include numbers like 4, 0, -6, and so we're going to shade the left side of that vertical line to represent our lesser or lower numbers. When you have a positive slope, again, you're going to shade below, but sometimes the lines can be drawn tricky. So if you're not sure which side is above or below, you pick a point on that line, and then you're going to draw an arrow down, and then find another one and draw an arrow down, and then that will let you know, okay, this is the side that we need to shade to represent a less than. And here we have a negative slope, so same thing. You pick a point, draw an arrow down, pick a point, draw an arrow down, and then that's the side that you're going to shade on to represent your lesser numbers. Less than or equal to is essentially the same with one difference. The shading will not change with the type of line that you have will. Because in equal to, we are going to change these dashes into solid lines, which means if they fall on the line, that would be included as part of our solution set. So we're going to review what a solution is coming up on the next part, because that's what we're going to be doing today, is finding our solutions. All right, so we're going to shade below, to the left, below, and below again. For greater than, again, there is not an equal to, so we're going to keep it dashed. And greater than means to get larger. So we want to head towards bigger numbers. So when we're looking at that -8, we want to head upwards towards the positives. So we're going to shade above that horizontal line. For our vertical, again, we're at 5, so greater numbers would be like 6 and 10. So we're going to shade to the right. For our positive slope, pick a point, draw an arrow upwards to get to that above shaded region. And same for our negative slope. Pick a couple points, and then that will let you know which side would be your, oops, I did the wrong direction on that one. Which side would be your greater than for the above direction. All right, greater than or equal to, same as before, same directions of shading, but the equal to means we are going to change these to solid lines to add to our solution set. And again, shading above or to the right in this case, above and above. All right, so that's our refreshers on our inequality symbols. Now we're going to combine multiple lines and find our official solution set. So you got some steps here to remind you how to graph. If you don't remember how to graph a Hoyle equation where it's just a y equals and no x, or a Vux equation where it's just an x equals, you've got hints there. It does remind you to decide whether you should have a solid or a dashed. Don't forget to decide the correct direction of shading, and we're going to do this for every single one. And then once we graph them all, our final solution, which we call a solution region, which will be our final shaded region, and that's going to be where all of the shadings overlap. So a reminder from your Algebra 1 days, two S's to make a solution. One of them would be it falls on a solid line. The other would be if it falls in the shaded region. Also a reminder that if it falls on dashes, dashes do not count because they are not equal to. So let's practice our graphing and then our shading to find our final solution set. Our first one is an mx plus b, and it does have an equal to, so this is going to be a solid line. We have a y-intercept of 2 and a slope of -1 over 2. So we're going to move down 1 and to the right 2 as far as we can go. Reverse your direction up 1 and left 2 again as far as you can go. And we said solid line. All right, now our shading, because it's a grader, we're going to shade above those points. And so draw your arrows if you need to, and then shade everything that is above that negative slope line. All right, next up is also an mx plus b. It does have both variables. The b part is not shown, which means that it's going to have a y-intercept at 0, 0. Our slope is a positive 2, so up 2 and to the right 1 as far as you can go. And then reverse that direction down 2 and to the left until you get the full graph covered. Now that one does not have an equal to, so these are going to be dashes. And our shading of that one, that is a less than, so we're going to draw an arrow down from those points to get our shaded region for that one line. And then you can see that our colors are starting to mix, and our final answer is going to be where all the colors mix. All right, last one up. X is greater than -6. That is a special case. You do not have both variables present. So you decide whether it is a Hoyle or a Vux. Because it has an X, you're going to use a Vux, which means it's going to be a vertical line. But it is not equal to, right? Our symbol doesn't have the underline, so we're going to do dashes when we draw this vertical line. Go to where your X is -6, and then give me some nice thick vertical dashes. Make it dramatic. It is a greater than, and so greater numbers would be to the right. And as you're shading, pay attention to where all three colors are represented, and that's going to be your final shaded area. So I'm going to go over mine where all three colors mix, and I'm going to make it the darkest. So I know that when I go to decide, do I have solutions, I know I'm only going to look in that area where all the three colors are going to be. So I'm being a little bit dramatic here. Just make sure you can still read to name some points. All right, so for part B, which order pairs are solutions? So let's check one at a time here. I'm going to use my little laser. All right, let's do 9, 3. So 9 would be here, up 3. That looks good. It's in our mixed shaded area. All right, -8 and -8. That's definitely a no. 2, 4 is on a dash. That's a no. 6, 7, and 2. That would be a yes. -1, 6. That's a no. 5, 5. That's a yes. 2, 1. That's a maybe because it's on a solid line, but it's not technically in there. So we're going to put a question mark because that's going to be our next layer is how do we know for sure when we're on like those boundary lines, like will it actually count? So we are actually going to go back to this portion. So just make sure you run that check later on after we learn it in the next two examples. All right, and then -4, 0 will be over here. So that one is a no. All right, let's try again. We've got a system, we've got 3. We've got a Vux with dashes because there is no underline. X is -4. Change my color. And that is a greater than symbol. So I'm going to shade mine a little bit differently. Instead of having all the colors, I'm just going to draw some arrows for now, and I'm only going to shade in my final region. All right, our next one does not have both variables, so special case, but this time it's a Y. So that is what we call a HOI, which will be a horizontal line. This is on the Y-axis at -5. It is a greater than or equal to, so it is going to be a solid line this time. And then greater than would be above. So we're mixing right now, technically in this area, but we do have a third line. So let's go ahead and look at that one. This one is in standard form, so let's go ahead and convert that to slope intercept form so we can graph it. Subtract our 3x, and then our y is already isolated. So we're going to graph -3x plus 7. It does have an equal to, so it will be a solid line. Our y-intercept is at 7. Our slope is -3, so down 3 and to the right 1, edge to edge of the graph, and then reverse it up 3, left 1. We said solid line. And then we are less than, so we're going to shade downwards. So my final region, I'm going to shade it in purple, will be eventually a triangle when they intersect somewhere at the top. So here's our final shaded region for our solution set. All right, let's check our points. So we've got 0, -6, that would be down here in white, that's a no. We've got 1, 1, that is in our mixed shaded region, that's a yes. We've got 2, 1, and again, that's one of those, are we sure or not? So I'm going to put a question mark because we're going to learn how to check that and verify whether it is or is not. We're going to have a -4, -3, that's on dashes, so that's a no. We've got 3, 4, 5, 6, 7, 0, -2, and 8, that's a yes. -9, 0 out here in the white, that's a no. And 0, 10, also up here in the white, that one is a no. All right, so let's see. Use substitution to determine if T1 is a solution. So to verify a solution, you're going to plug in the coordinates into every inequality in the system, and they all have to give you a true statement. As soon as you get a false, it's automatically a no, not a solution. So we're going to take this ordered pair, 2, 1. We have an x coordinate and a y coordinate, and we're going to plug it in one at a time. Our first one was x is greater than -4. So our x coordinate is a 2, and we have to decide, is 2 greater than -4? Positives are bigger or larger than negative numbers, so that's going to be a true statement, a yes. All right, next one over, y is greater than or equal to -5. Our y is a 1. Ask yourself if 1 is greater than or equal to -5. So same thing, positives are greater than negatives, so that's a true statement. Our last inequality, and you always want to go with the original, is in standard form. So we're going to plug in the x value of a 2 and the y value of a 1. And then to determine whether it's true or false, you're going to simplify left side and then simplify right side and then compare those two numbers. So 3 times 2 plus 1, you can do that in your head or type it in, and that is going to be a 7. And you have to decide, is 7 less than or equal to 7? Well, 7 is definitely not less than, but it is equal to 7, so this is true. So because it works for every inequality in your system, you're going to say that it is a solution because all 3 inequalities are true. They might also use the word are validated. Validated means that you have verified that it is a true statement. So 2, 1 is going to be added to our yes list.